Okay, let's do this part 2 the July 2020 series. We have three currents, I1, I2 and I3 in a passive DC network. Satisfy the simultaneous equation I1 minus I2 plus 2I3 equals to 6, negative I1 plus 2I2 minus 3I3 equals to negative 8, and negative 2I1 plus I2 plus 2I3 equals to 5, where I1, I2 and I3 are in amperes. Then we have to use the inverse matrix method to solve the equation. So for those who are not electricians, please don't panic, these are just currents. So we'll extract the matrix. So if I extract directly here, let me use this green one. So we'll have a 3 by 3 matrix since we have I1, I2 and I3. So here we take the cofactors, the coefficients, sorry. So this is a coefficient, this here, the 1, which is a coefficient, then this 2 is a coefficient. So the first row we take the coefficient 1, then negative 1, then 2. Then for the second row we have negative here, so it will be negative 1, negative 1, then 2, 2 and negative 3 here. Then this last row it is negative 2, then 1 positive, then 2, like that. We have formed that. Next we form a matrix of the unknowns. We have current 1, current 2 and current 3, like this. So we equate to 6, we have negative 8 and then 5, like that. So we have to find, overextended this one, so we have to find the inverse of this matrix here. Let me call it matrix A. So this matrix we have to find its inverse. So if I will write, we have A. Let us find the inverse of the matrix 1, negative 1. We have 2 here. We have negative 1, 2, negative 3. We have negative 2, 1 and 2. So here we have the matrix which we need to find its inverse. So what is the inverse of a matrix? The inverse of a 3 by 3 matrix, we have the formula adjoint of the matrix A divided by the determinant of the matrix. So what is the adjoint of a matrix? So to determine the adjoint of a matrix, we have to find first the determinant of the 2 by 2 matrix. For example, for this one, this element here, this element 1, what we do is that we eliminate the row concerned with it and the column concerned with this matrix. Then we take this 2 by 2 matrix, we find its determinant, then we replace at 1. Then for negative 1 we block out the row concerned with it and the column. So if I illustrate using red, so for this one we block out this and then its column, and we take this elements to form a 2 by 2 matrix, then find the determinant and replace here all the elements. So like that. So let's first determine the determinant of this matrix. So for determinant, let me write determinant, determinant. So for determinant of this matrix, we'll select any row. So let's take row number 2. So I have taken row 2 to be the study row to determine the determinant. So for row 2, if you remember the sign matrix, it is positive, negative, positive, and negative, positive, negative, then positive, negative, positive. This is a sign matrix. So we have for row 2, this row 2, we have negative, positive, negative. So the first element will be affected by negative. We will have negative 1. Then we form the 2 by 2 matrix by covering this negative 1 is concerned with this row and this column. So we'll remain with negative 1, 2, then 1 and 2, like that. Then next is positive, so positive 2. Then for 2, when we block this column and this row, we have 1, 2, negative 2, 2. So we'll have 1, 2, negative 2, 2, like that. Then negative, negative, negative 3. So this will give us a positive 3. Then block this column and this row, we have 1, negative 1, negative 2, 1. So 1, negative 1, negative 2, 1. So like that. So what will happen next? Let's calculate here. So we'll have negative 1, but remember we had a negative here, so this one will be positive. So this 1 into, then we calculate 1, negative 1 times 2 minus 2 times 1. So what will this give us? It will give us negative 4, negative 4. So I'm changing colors so much. Then plus 2 into this is 2 minus 2 minus 4, that is 6. Yes, plus 3 into 1 minus 2, that is negative 1. So if you calculate, we get a 5. That is our determinant. So I've taken row number 2, take row number 1, but then consider these signs. If you take row number 1, take row number 3, consider this sign. It affects these letters, these numbers of the front. So we have found the determinant. Let's proceed to determine the cofactor matrix. The cofactor. We determine the cofactor matrix. So like that. So the cofactor matrix, let me use black. So we have seen for row number 2, we have found the matrix that we can replace for every element in this row. So we only calculate for row number 1 and row number 2. If you don't get it clearly, please you can use the math book known as John Bird. engineers will understand, then come back to the video. So let's do row number 1. Let me rewrite the matrix A here. So the matrix which we are referring to as A was 1, negative 1, then 2, and we have negative 1, 2, negative 3, then we have negative 2, 1, and 2. So this is the matrix we are analyzing. So let's do for row number 1, row 1, let me use green. For row number 1 we have 1. This one, if we cover it and cover its row and columns, we rename it 2, negative 3, 1, 2. So we will have the number 1. So it will give 2, negative 3, 1, 2. So if we find the determinant, it is 2 times 2, 4 minus 3, negative 3 times 1. So 4 minus that will get a 7. Then the next element is negative 1. So for negative 1, if we block its column and row, we have negative 1, negative 3, negative 1, negative 3, and negative 2, 2, negative 2, and 2. So this will give us negative 1 times 2, negative 2 minus negative 3 times negative 2, that is 6. So it is negative 2 minus 6, that is negative 8. So I will write here negative 8. I hope you see. Then we have the under row 1, the last element is 2. Block this row, this column, and this row. We have negative 1, negative 1, 2, and negative 2, 1, like this. So this will give us what? Negative 1 times 1 is negative 1 minus negative 4. We will get what? Negative 1. So this will be plus, this will be 3. Okay. So we proceed to row number 2. Let's redo it. Let's not assume. So row number 2. Row number 2, if I use a different color, so we'll have for negative 1, it's 2 by 2 matrix. If we block here and here, we have negative 1, 2, negative 1, 2, then 1, 2, 1, 2. So this will give you negative 2. This negative 1 times 2, negative 2 minus 2. Negative 2 minus 2, that is negative 4. Okay. Then we have element 2. If we block its row and its column, we have 1, 2, 1, 2, then negative 2, 2, negative 2, 2, like this. So this will give us 2 minus 4, this will be 6. Okay, that is 6. Then we have the last element, negative 3. It will give us what? So block this and this, we have 1, negative 1. Then we have negative 2, 1, negative 2, 1. So this will give us 1 times 1, 1. So 1 minus 2, negative 1. Then we complete, we finish with the row number 3. We have to add some pages here. So we have row number is too big. Let me erase it. So we have row row number 3 like that. So row number 3 with negative 2, 1 and 2. So if we block negative 2, we get negative 1, 2, 2, negative 3. So the first element, let me change color, we use this. So we have negative 2, it will give us which 2 by 2 matrix. This is big, so it will give us which negative, so negative 1, 2, 2, negative 3. We'll have negative 1, 2, 2, negative 3 like that. So negative 1, 2, 2, negative 3, correct. So this one will give us 3, leading diagonal is 3 minus 4, this is negative 1. Then we go with 1. If we block this column and this row, we have 1, 2, negative 1, negative 3. So for 1, we have, what will 1 give? It will give 1, 2, negative 1, negative 3. Hope you are following. So this is negative 3 minus 2, negative, this is negative 3 minus, get again negative 2. This will give us what? Negative 1. And that is correct. Then the last is 2. If you block its column and row, we get 1, negative 1, negative 1, 2. So for 2, so we get 1, negative 1. Is it like that? 1, negative 1, negative 1, 2. Okay. So this is 2. We do 2 minus 1, which is 1. Okay, so we have formed the matrix. So our matrix, let me just call it matrix. I think we should use black here. Our matrix will be, what will our matrix be? So we take the row 1, we have 7, negative 8, 3. So we have 7, negative 8, 3. Then we have negative 4, 6, negative 1. So negative 4, 6, negative 1. And then we have negative 1, negative 1, negative 1, and 1. So we have this matrix. Now we have to, what is the next? We have to multiply it by the sign matrix. So what is the sign matrix is positive, negative, positive, then negative, positive, negative, then positive, negative, positive. This is what we call the sign matrix. So what will it give? So 7 times positive, let me form this. This is positive 7, negative 8 times negative is 8, then 3, it remains 3, then negative 4 becomes 4, 6 becomes, it is just 6, negative 1 becomes 1. Think you're following. Then we have negative 1 times positive is negative 1, then negative 1 times negative, it is 1, then 1 times positive is 1. So this is our matrix, which we must call A. So we find the adjoint of this matrix A, this immediate matrix. What is the adjoint? Adjoint of the matrix A. now the adjoint is just the transpose, where we take the, for example, we take this row, first row to be the first column, so we'll have 7, 8, sorry for the 8 and 3. Then the second row will be the second column, which is 4, 6 and 1. Then we'll have the third row to be the third column, negative 1, 1 and 1. Like, let me use a different color. There, so we have this. Now this is our adjoint. This is our adjoint of this matrix. So remember, our intention was to calculate what the inverse of our matrix. This is our formula for the inverse, which is the adjoint we have found, and the determinant is here. So let's compile. We now say that the inverse of matrix A, the inverse is the adjoint. So let's put the determinant as a fraction. Then let's follow with our adjoint. 7, 4, negative 1, then 8, 6, 1, 3, 1, 1. This is our this is the inverse. This is the inverse of the A matrix. Okay, now if we have found the inverse, that was the first step, we have found the inverse. Now we multiply the inverse on both sides of this big statement. I think we can rewrite it somewhere down here. Let me see. So we can rewrite it as 1, negative 1, 2, because I have to explain something. Negative 1, 2, negative 3, and we have negative 2, 1 and 2, just like this. Then we have current 1, current 2, or from an engineers you may say I1, I2. So like this equals to equal to 6, negative 8, 5, like that. Yes. So we have to multiply now our inverse on both sides of the equation. If you multiply a matrix by its inverse, you get the, for example, if you take A times its inverse, like that, you will get the identity matrix of the same structure. So at this point we will have the identity, which is 0, 1, 0, 0, then 0, 1, 0, then 0, 0, 1. So there is no need of multiplying this matrix, since we get what we already know. We get the identity matrix. Although sometimes here, let me highlight, sometimes at this point you might get just a number on this leading diagonal. Maybe it might be 3, 3, 3. Still it is an identity. So the only point where we'll have our emphasis is this last bit. So we have 7, 4, and negative 1, if I'm not wrong. Then we have 8, 6, 1, then we have 3, 1, 1, like this. Then we have the original part, 6, negative 8, and 5, just like this. Okay, now let's complete this part by multiplying now directly. So we'll have I1 current 2 and current 3 like this, which will be equal to let's maintain the determinant. Let's maintain. So like this we'll do, we'll have to calculate, we'll have to multiply, which you know it is row and column. In this case we have one column, so all rows and the column, all rows and the one column, like that. So what will it be? We'll have 7. We'll have let me use a green color. So we'll have 7 times 6 plus 4. We'll have 4 times negative 8, then added to negative 1 times 5. Deleted that. Let me use this color. Then we have 8 times 6 added to 6 times negative 8 added to 1 times 5, like that. Then last one we have 3 times 6 added to 1 times negative 8 plus 1 times 5, like that. So we will get what? We get 1 divided by 5. Then if you calculate the first one, we will get 5. Why? This is 42. So we'll get 7 times 6. We'll get 42. 42 plus negative 32. How much? That will be 10. So if you take 10 plus negative 5, you get a 5. Next one we will get also a 5. This multiply, and the last one is a 15. So if you multiply 1/5 to all, we will get 1 and 3. So now our current I1 will be 1 ampere. Then current 2 will be also 1 ampere, and current 3 will be 3 amperes. Now we can confirm. Let's confirm using the equation negative I1, take an equation, plus 2 I2, then minus 3 I3, which gives us negative 8. So if we replace, current 1 is negative 1, so let's put negative 1. Current 1 is 1, so negative, then plus 2. Current 2 is also 1, then minus 3 into current 3 is 3. Will it give us negative 8? So this is negative 1 plus 2, that is 1 minus 9. Is it negative 8? Yes, it is negative 8, negative 8. So that means you got this correct. These are the results of the calculating the finding the carries. So now you have your answer of the calculating this problem using the inverse matrix method. Please do not change the instruction. Do not use another method. Use just the inverse matrix method. Which method do we have? There are many methods apart from the inverse matrix method. Thank you.